We're going to be talking about partial fractions. Partial fractions. Okay. Our example problem for today is going to be x plus 7 over x squared minus x minus 6. So you can't do anything with the numerator, so you're going to have to factor out the denominator to split it up into two different fractions. So to factor out this, you would be x minus 3, and you would have plus x plus 2. And then you don't know what the numerator is, so you would have a and b. The next step you would want to do is have x plus, you would want to multiply these together to get the same denominator. So you multiply this side by x plus 2 and this side by x minus 3 to get a to the x plus 2 plus b to the x minus 3 is equal to x plus 7, because they have the same denominator. The next step you'd want to do is multiply the... Okay, the next step you want to do is multiply a throughout x plus 2. So you'd have a to the x plus 2a plus, you multiply b out to get b plus b of x minus 3b is equal to x plus 7. So you have the x's here, so this is 1x is equal to a of x plus b of x. So you take out the x's and you would have 1 is equal to a plus b. And then for this part you would have 7 is equal to 2a minus 3b. 2a minus 3b is equal to 7. So you'd want to get one of the variables by doing a is equal to 1 minus b. Then you would plug in a for this equation to get 2 minus 2b minus 3b is equal to 7. So then you would subtract here to get 5 is equal to minus 5b to get b is equal to minus 1. You would plug in minus 1 to here to get 7 is equal to 2a plus 3. So then it'll make it so a is equal to 2, because 7 minus 3 is 4, and then you divide it by 2, which will make a equal to 2. Then the last step you would want to do is plug these back into here to get 2 over x minus 3, and then because it's minus 1 you would subtract 1 over x plus 2, and that is how you do partial fractions.
So now we'll move on to a more advanced problem. Here we're trying to convert this into multiple fractions. So we have 5x squared plus 20x plus 6 over x times x plus 1 squared. And since, again, like the previous example, we have to try to make the denominator, we have to try to factor out the denominators. So what we would do here, in this case, is that x would be here, and then plus x plus 1. And here what we would do is, you would have to do x plus 1 squared. Since this is a partial fraction, this is a rule. You have to do x plus 1 squared and x plus 1. And so here, again, we'd have a, and then b, and c. And then now here we would try to get the same denominator as this again for each of these fractions, so that we can combine them together and cancel out the denominator. So here, what we need to do is multiply by x plus 1 squared and x plus 1 squared. Now, see, we don't multiply this here by x plus 1 as well, because then that wouldn't give us this denominator. So, and here we would multiply this by x plus 1 and x as well, so that we get the same denominator. And here we would only have to multiply by x, since it's already x plus 1 squared, and you just need an x to make it that denominator. And so if we simplify this, we'll get a times x plus 1 squared plus bx x plus 1 plus cx, and this will be over x times x plus 1. And since we now have the same denominator, we can cancel these two out, and we will get 5x squared plus 20x plus 6 is equal to a x squared plus 2ax plus a plus bx squared plus bx plus c.
Here is Shashank with glasses coming on for part 2.
So now, since we have the simplified equation, we can now match the values of the coefficients to their variables. So we have ax squared plus bx squared has to equal to 5x squared. So a plus b has to equal to 5. Similarly, 20x, so we find all the coefficients with an x variable, x to the power of 1. So that's 2ax plus bx plus cx equals to 20x. So we can see that 2a plus b plus c equals to 20. Now, since we have only the constant, which has a variable of x to the power of 0, we can match that to a, which has a variable of x to the power of 0. So a equals 6. Since we have the value of a, we can now substitute it into the first equation and find that a plus b equals to 5. Therefore, 6 plus b equals to 5. And b equals to -1. Since we have the value of b, we can now substitute into the second equation, and we find that 2a minus b plus b plus c equals to 20. So c will equal to 20 minus 11, which equals to 9. Since we have the values of the three coefficients, we can now substitute them back into the original equation. Since a is equal to 6, we find that it's 6 over x. Since b equals -1, it will be minus 1 over x plus 1. Since c equals 9, we see that it's 9 over x plus 1 whole squared. And there ends our equation.
For this next problem, Jay will be teaching it in Chinese. And here comes Jay with that beautiful smile of his, always so dashing.
Ching chong ding dong, ring ring ding dong, konnichiwa.
Jay, just please don't do that. Just do it in English, dude, please.
Do you have something against my culture or something?
No, that's not what I meant. It's just
Racist.
Oh my.
Whatever. So this problem is a little different from the other problems that we did, because this one, so you'll see the difference after we start factoring this. So here, because there's an x in both of the terms, so x, you factor out the x, and then it would be x squared plus 4. So this, at first glance, this looks like you can factor it more, but actually x squared plus 4, you can't factor that anymore. If it was x squared minus 4, you would be able to factor it into x plus 4 and x minus 4, but we can't factor this anymore. So we know the denominator for the first, and there's nothing like x squared here, because if there was that, then we would need 3 different fractions, but it's just x. So one fraction is fine for this. So the first one would be x, and then the second one would be something over x squared plus 4. So this one, we can just do this like any other problem that we just did. So something over x. Yeah, so that would be a over x. But then here, because there's 2 terms here, which is different from anything that we had earlier, then we would have the top be bx. So this x would be one to the one less power than the bottom. So x squared, so then the top one would just be x, and then plus just a normal number like a, bx plus c. And then from here, we'll just solve it like the other problems. So if we want to make the denominator the same so we can get rid of the denominator on both sides, then we'll multiply a by x squared plus 4, a times x squared plus 4, and then plus x times bx plus c. So if we multiply that out, ax squared plus 4 plus 4a plus bx squared plus cx. And then from here, you see the x squared, there's x squares here, and then for the x squared, we just look at, there's an x squared here too. So we just look at the coefficients because there's 3 x squares, which is 3 times x squared, and then there's a x squares, and there's a b amount of x squared here. So if we just get rid of the coefficients, then that would be 3 equals a plus b, and that's the first equation we can use to try to find the variables a, b, and c. And then the next one is 4x. So we see that it has x to the power of 1, and then this also has x to the power of 1, and that's it, nothing else. So if we get rid of the variables here, then we'll see 4 equals c, which is really handy because now we don't need to go to plug this in into anything else. We don't need to try to solve for c because it's already given. And then the last one is 4a is 4 because these are the ones without a variable, without x in it. So 4a equals 4. This is also really handy because there's no other variables. There's only a in here. There's not a plus b or anything else. So we just divide each side by 4, and then we realize that a equals 1. So a equals 1. And then a plus b equals 3. So if this is 1, then b must be 2. So a equals 1, b equals 2, and c is given. c equals 4. So you plug this back in to find the partial fraction. So that would be 1 over x plus b. And then remember, you still need to include the x. So that would be 2x plus c is 4 plus 4 over x squared plus 4, and this is the solution, it's the partial fraction.